this video, we'll show you how to make a program for the FreePower Charging Station. First, let's take a look at the tooling being used. The two tools are provided by FreePower. One is a 50mm gauge wheel and the other a vacuum brazed bit. All of the drawing information and a DXF is also provided by FreePower. I'll use this DXF to program a pocket on our Titan the same as in the video. We'll start by adding the tools into our library. I'll go to the Machine tab and then select Define Tool. Both of these tools will be flat end tools. I have pocket number 21 available on my Titan, and the offset number should be the same. The tool's length is 0.94 and its diameter is 2.11. I'll always choose to have flood turned on, the units in inch, spindle rotation clockwise, and the fixed feed rate for this tool for the material I'm cutting is a spindle speed of 5500, the fixed feed of 80 inches a minute. I'm going to feed down slow, maybe 32, then I'll say OK, and I'll save this tool into my Titan 4800 library. The vacuum brazed bit is also a flat end tool. This one will go into pocket number 22. The offset number should be the same, and its length is 1.965 and its diameter 0.495. We'll also leave flood checked, units to an inch, rotation clockwise, an RPM of 6,000, a feed rate of 40, and a down feed of 20. And then I can save this vacuum brazed bit into my library as well. And now I can prepare my shape for pocketing by setting tool direction. In this shape being a closed geometry, I'll cut to the inside, counterclockwise, and then I'll manually set the start point. I'm going to set the start point towards the middle of a long side. And before setting up our cutting parameters, we'll select the tool by double-clicking on the name and then click anywhere into the drawing to make it active. Then we can choose pocketing. We'll leave the defaults under the Types tab, Vertical, and Selected. Under General, we'll verify that we have the correct tool selected. If not, we could change it. We'll use a contour type of pocketing, and we'll set our high-speed feed rate to 2,360 for our Titan 4800. The mill type we'll leave set to climb, and we'll turn on high-speed cornering. And next, we'll go to levels and cuts. We'll leave the safe rapid level at 5, but we'll change the rapid down to 2 inches. The material top, our 3cm quartz, we'll set to 1.2, and then the final depth will be the final thickness of our pocket, which we'll set to 0.2. The max depth per cut we're going to set to a very small amount, 0.065 or 65 thousandths per pass. The XY corners we'll leave to straight, and we're going to change the tool entry approach type to a ramp. And we'll turn off center cutting tool, and we'll set the angle very gentle at maybe 5 degrees. I'm also going to set my maximum plunge depth to 65 thousandths, the same as my max depth per cut. Under the Machining Data tab, I'm going to change the XY stock to be left to 0.015, 15 thousandths, to leave a little to clean up with my vacuum brazed bit. I'm going to change the link method to stay at depth to reduce movement. I'll leave the rest of the settings default or as shown. I could adjust any tool data if needed, or click on OK to apply my cut to my geometry. I'm going to switch to an isometric view just to see that I have many steps down and that my lead-ins are at gentle slopes or angles. Now let's stop for a minute and talk about the size of the pocket. These dimensions are very important and must be kept within FreePower's tolerances. Our objective is to, first of all, use the gauge wheel and leave a little stock to be left, and then have our vacuum braze bit clean it up to finish size. So it's very important that the tool diameter works correctly to cut our pocket to an accurate size. If the tool is physically larger than we've entered into AlphaCam, the size of the pocket will be too large and our cleanup tool won't even touch. And if the physical tool is smaller than entered into AlphaCam, the pocket will be cut way too small and put way too much pressure on our cleanup tool. AlphaCam's pocketing cycle does not use tool diameter compensation at the machine. It uses the tool diameter from the AlphaCam tool library. So we'll want to verify that our gauge wheel is cutting accurately, which would be the easiest to do by applying a pocketing path without stock to be left. Then we can measure and ensure that it's cut to the finished size. This can be done in a scrap piece of material or possibly a smaller pocket within the pocket that we need to make to prevent it from being oversized and out of tolerance. If we need to change the size, we'll need to change AlphaCam's tool diameter because the pocketing cycle does not use the diameter in the machine's tool library. So I'll have to edit the tool and change the diameter to change the size of my part. If I change the diameter of my tool smaller by 100 thousandths or 0.1 and then save my changes, I can then edit the tool path by reinserting the tool with the new diameter change. So I'll right-click and choose Edit, and then choose to change the tool, double-click on my newly edited tool, and then click once to set it into the drawing, before I click OK to update my tool path, which moves closer to the edge of the geometry to accommodate a smaller tool. This will make my part larger because the physical size of the tool has not changed. And the overall size increase is the same amount that I made my tool smaller, 100 thou or 0.1. And if I want to make my pocket smaller, I could go change the size of the tool to larger than what it was programmed, and update the tool path to the new larger tool to make the overall width of my pocket smaller by the value that I use to make my tool diameter larger. We need to make a program with zero stock to be left and have the program physically cut the part the same size as it was in the drawing. The diameter of our vacuum braze bit may also need to be adjusted so that the edge of it and the gauge wheel will refer to the same location. I'm going to make the cleanup pass next. When I do, I'm going to choose to use AlphaCam's tool library diameter for my vacuum braze bit, just as we did for the gauge wheel, so they can both be adjusted in the same manner. I'll start by selecting the tool and then clicking in the drawing to make it active before I go to Cut Shape. I'm not going to change any of the defaults on the first Types tab, and under the General tab, I'll verify that we have the correct tool selected. I'm going to use Tool Center for compensation, so if it needs to be adjusted, it will be done in the same manner as we showed how to do with the gauge wheel. And we'll leave XY corner set to straight. On the Levels and Cuts tab, I'm going to leave the Safe Rapid level set to 5. I'm going to change the rapid down to 3/4 of an inch and call the material top 0.2 and the final depth 0.2. 0.2 was the final thickness after I cut my pocket. So now it can become the top of the material for my cleanup pass. And I don't want to change the thickness of my pocket with this tool, so I'll keep the final depth set the same. There's nothing to change under machining data, but we are going to create a gentle lead in and lead out. And we'll start with turning them on, and then we'll set the lead in to both. We're going to set both the lead in and lead out the same. We'll ask for a sloping lead in and lead out, and we'll turn on line and arc tangential, and we'll set the length of the line to be at about 10 times the radius of the tool, the arc radius about twice the radius of the tool. We'll use a gradual approach angle, maybe about 70 degrees. And then I'm just going to press this transfer all the lead in information to the lead out. And there shouldn't be anything we need to change under tool data. So we'll click OK and apply this cut to our geometry. Our leads have a nice gentle lead in and fit within our pocket. And if we go to an isometric view, we can see the gentle ramp down as well. We're also going to need to verify the alpha cam tool diameter for this tool. So first, we'd verify that the gauge wheel is cutting to the correct size out of the machine, and then we could use that pocket that was cut without stock to be left to carefully run this tool into. And we'd hope that both tools would cut to the same location. If not, we could adjust the vacuum braze bit like we did the gauge wheel. And when both tools are verified, then we can create the final program, which will be the contour pocket rough that had the 0.015 stock to be left set in it, and then making the finish pass to remove that with our vacuum braze bit to clean it up. And this roughing and finishing pass will complete our program for our pocket. We'll definitely want to run it through simulation first to verify that it's going to do what we intended, and also to watch the lead in and lead outs. And when these cuts are tested and proven, don't forget to save them as a style. Watch our video on creating styles if needed. And as always, thank you for choosing Park Industries.